Hello guys, can we take a minute or two to show that tan1 is irrational? So in reality we want to show that tan1 is irrational, and let's see how we are going to go about that. Recall that Q is the set of rational numbers. So because I want to prove by contradiction, that is why I just need to recall some things. Q is a set such that you can write it as a fraction. Any number you can write as a fraction is called rational. So now, if we take two elements, this is also part of the property closure property on the basic operation on the set of rational number. If we take any two elements from the set of rational number and you sum it together, if you take any two rational number and you sum it, n plus n, the answer you will get will still be a rational number. That's what this means. If you subtract any two rational numbers, if you pick any two rational number, maybe 1 over 4 minus 1 over 2, the answer will be negative 1 over 4. It is still inside a rational number. Once I can write it as a fraction, it is a rational number. So if I add two rational numbers, the answer we obtain will be a rational number. If I subtract it, it will also be a rational number. If I multiply two rational numbers, 1 over 4 multiplied by 1 over 2, the answer will be 1 over 8. You see, it is still a rational number. And if I divide it, the answer I will get will still be a rational number. So you need to take note of that. So now let's come to the main proof. The proof is we want to prove that tan1 is inside a set of irrational numbers, Q complement, or say tan1 is not a rational number, it's not inside Q. Now we prove by contradiction. Well, what is the contradiction? Suppose for contradiction that tan1 is rational. So tan2, which is equal to tan1 plus 1, tan2 is which is equal to tan1 plus 1, and we know that we know the addition formula for tan. This is equal to 2 tan1 all over 1 minus tan square 1. I just use the addition formula for tan a plus b. That will be tan a plus tan b all over 1 minus tan a tan b. So tan1 plus 1, tan2 which is equal to tan1 plus 1 will also be rational because 2 multiplied by any rational number is rational. Divided by, so tan1 we have assumed that tan1 is rational. So 2 multiplied by a rational number is rational. If you square a rational number, the answer will still be a rational number. And if you subtract, if you take 1 from it, it will still be a rational number. So my point is, what is at the numerator here is a rational number, and what is at the denominator is also a rational number. So this one, it means that this is also a rational number. So it means that tan2 is a rational number. And if tan2 is a rational number, it means that tan4 is equal to tan2 plus 2. Tan2 plus 2 is tan4. So this will give me 2 tan2 all over 1 minus tan square 2. You know, we have assumed that tan1 is rational. Because of that, 2 tan1 all over 1 minus tan square 1 is also rational, and that's exactly tan2. Because of that, tan4, according to what we have assumed here, tan4 will also be rational, because this is what is up here is rational, what is down here is rational by our assumption. So it follows like that tan8, which is also equal to tan4 plus 4, which is equal to tan4 plus tan4 all over 1 minus tan square 4 will also be rational. from our assumption. So if we go on like that, tan 16 and which is equal to tan 8 plus tan 8 all over 1 minus tan square 8 will also be rational, will also be a set of cube. Then it follows again that tan 32 will be tan 16 plus tan 16 all over 1 minus tan square 16 will also be a rational number. So where am I going to? Now tan 30, which is equal to tan 32 minus 2. Tan 32 minus 2 will give me tan 32 minus tan 2 all over 1 minus tan 32 tan 2. Now, what am I trying to say here? Look at it. From what I have assumed, I assume that tan 1 is rational, and because of that, it implies that tan 2, as I have showed you above, tan 4, tan 8, tan 16, tan 32 are all rational from the assumption. So tan 30, which is equal to tan 32 minus 2, this is a rational number. Tan 32 is rational, tan 2 is rational. If you subtract two rational numbers, you get a rational number. If you multiply two rational numbers, you get a rational number. 1 minus a rational number will give you a rational number, and when you divide the rational number, it will still be a rational number. So what this is trying to say is that tan 30 is also a rational number, but we know that tan 30 is obviously 1 over root 3, but 1 over root 3 is never a rational number. Tan 30 is equal to 1 over root 3 and it's not a rational number. So we arrive at a contradiction because our assumption says that brought us to tan 30 to be inside a set of rational numbers. So, but it is not a rational number. So we arrive at a contradiction. And that means that our assumption is wrong. Thus, tan 1 is irrational. Thank you very much.